Welcome to the U.S. Military Test Prep channel by Study.com. My name is Eric, Marine Corps veteran, and I'm an ASVAB test prep expert. In today's video, we'll practice performing computations and writing numerical expressions with squares and square roots of positive rational numbers. This will help you prepare for the Arithmetic Reasoning exam, which is one of the subject-specific sections of the ASVAB. Let's take a look at our first problem. Determine the simplified form of the expression x to the third, y to the sixth, z squared, divided by x to the fourth, y to the fifth, z cubed. Is it x to the seventh, y to the 11th, z to the fifth, z divided by y, x squared divided by yz squared, y divided by xz? So to work out a problem like this, let's just review really quickly what it looks like when we divide variables that have exponents. So if I had, just for example, x squared divided by x, then we can kind of subtract the exponents, and then that helps us land in the right spot. So let's look at it another way. This would be the same thing as saying x times x divided by x, which is the same thing as saying x over 1 times x over x. If we multiplied this across, we would get x squared divided by x. So now we have kind of an idea of what we're looking at. So let's come back to this example here, and we've probably seen something like this before. When you have kind of something on the top and then something the same on the bottom, those can kind of cancel out, and what you get left with is x over 1, or x. So this expression simplifies to x. All right, so now that we know what that looks like, let's go back to our original problem and see if we can work this out. So another way to write this to achieve the same thing is we could say x to the third, because that's up here in the numerator, minus the denominator x, which is 4 right here. And then we just kind of do that across, times y to the sixth, so that's up here in the numerator, minus 5, because we've got the 5 in the denominator, times z squared minus 3, just following the same pattern. So then if we work each of those out, we get x, and then 3 minus 4 equals negative 1, times y, and then 6 minus 5 equals 1, times z, and then 2 minus 3 equals negative 1. So just as a reminder, if we have, an x to the negative 1, that's the same as saying 1 divided by x. So we'll use that over here. So now what we have is 1 over x times, and then y to the first power is y over 1 times, and then z to the negative 1 is 1 over z. And if we multiply that across, we get 1 times y times 1 equals y, divided by x times 1 times z equals x times z. So that's our answer, y over x times z. Great job. Determine the solution to this expression. Negative 9 root 25 plus 3 root 2 plus 8 root 4 minus 2 root 2. Is it negative 61 minus root 2, 20 root 2, negative 28, or negative 29 plus root 2? So I'm just going to throw our order of operations back up here so that we can see them. That'll be a good reminder to work out a problem like this. Because you can see we have negatives and we have positives, we have plus and minus, and so it's important that we remember the order that we do things in. But one thing that might be a little bit tricky is, what do we do with all these roots? And it's important to remember that a square root is really an exponent, and so we're going to deal with those first. So let's just do a quick example here. If I have the square root of 2, that's the same as saying 2 to the power of 1/2. So we're going to deal with those exponents first as best we can. So what we're going to do is find what we call the perfect roots first, because it just helps to simplify the problem. And a perfect root basically means when you solve the root problem, you end up with a good, clean, whole number. So that negative 9 root 25 is a perfect example. So it's negative 9, but then the square root of 25 is a perfect root because the square root of 25 is 5. So we'll just say times 5. And that kind of cleans up the problem a lot for us. Then we have plus 3, and the square root of 2 is not a perfect root. It's going to give us this kind of ugly decimal place. So we can just go ahead and, for the sake of cleanliness, we can just leave that as a root 2 plus 8. And then 4 is another great perfect root because the square root of 4 is 2. So we'll just say times 2 minus 2, and we know that the square root of 2 is not a perfect root. So we'll just leave that in square root form because that helps keep this a lot simpler. So now negative 9 times 5 equals negative 45 plus 3 root 2 plus, and then 8 times 2 is 16 minus 2 root 2. So now we can kind of combine the whole numbers and then the root numbers. So negative 45 plus 16 equals negative 29 plus, and then 3 minus 2 root 2 equals 1 times root 2, or just root 2. And we can leave that root 2 just like that. That's our answer right there. Negative 29 plus root 2. Great job. Write in numerical form the following verbal expression. Square root of 7/3 plus square of 3/4 minus the square root of 1/2. So to solve this problem, basically all we have to do is really read the problem carefully and write down the problem correctly. So let's break it down into its individual parts. So we're going to start with this first part here, square root of 7/3. That's before this sort of plus operator. So I think we can probably figure that out. If we think about it by itself, it's the square root of 7 divided by 3, or 7/3. Now we've got our operator here, plus the square of 3/4. And that's kind of everything up until this next operator. So the square of 3/4, that's going to be the square of it, minus the square root of 1/2. So then we've got square root again, 1/2. So that's our answer. Square root of 7/3 plus the square of 3/4 minus square root of 1/2. Great job. Determine the simplified form of the root of 1008. Is it 12 root 7, 144 root 7, 15 root 6, or 8 root 10? So basically what we're trying to do in this problem is simplify it. So if we just rewrite this square root of 1008, what we're trying to do is break this apart a little bit into simpler terms. So we're trying to find some things that we can divide it by. So if we give ourselves a nice long square root here so that we can do some stuff in here, what we're trying to do is pull out something that would be a perfect root. So what can we divide 1008 by that would be a perfect root? So if we start just counting up from 1, 1, 2, 2 we know is not a perfect root, 3 is not a perfect root, but 4 is a perfect root. And we have a nice even number here in 1008, so let's try that one. 4 times 252. So 4 times 252 equals 1008. And what's nice about this is it's kind of the same thing as saying square root of 4 times the square root of 252. It's the same thing, but now we've separated out this nice perfect root, and we know the answer to that is 2 times the square root of 252. So now it's in simpler terms, but I think we can go even further. So what else could we do here? We've got 2 times, and we're going to give ourselves a nice long root again here so we can do some math. And this number is familiar. I think 36 times 7 is going to give us 252. And what's nice about that is this 36 is a nice perfect root again. So now we've got 2 times the square root of 36 times the square root of 7. And the square root of 36, of course, is 6. So if we keep working that out, it's 2 times 6 times square root of 7, or 12 times square root of 7. So that's our answer. Great job. Okay, that's the rundown on performing computations and writing numerical expressions with squares and square roots of positive rational numbers. The Study.com ASVAB course includes more information about what each subtest covers. The question content is similar to what you'll see on the ASVAB, and practice test scoring will be broken down by subtest for line score calculations. That can really help you see where you stand. If this video helped you out, give it a thumbs up. Drop a comment with questions or topics you want us to cover in the future, and don't forget to subscribe for more U.S. military test prep content. I'll see you in the next video. You've got this.